Welcome, everyone. This is Rich Berliner. I'll be your host today for the webinar. And we're going to start in about 1 minute. We're going to let everybody load in, and we will begin the webinar in about 1 minute. So I'll be back at that point. Okay, I think we're going to get going now. Peter, you can begin the process. Welcome, everyone, to our webinar today, Capitalize on the Benefits of CBRS-based Private LTE. I want to welcome all of you to our webinar, and I want to welcome our panelists today, Dr. Boo, who's VP of Mobility Strategy at CTS, and Jonathan Rowney, who is Head of Solutions Engineering for the Americas at Ranplan. And I'm going to be your moderator today. I'm Rich Berliner from Connected Real Estate Magazine and 5th Gen Media. Gentlemen, welcome. Thank you for being here today. And I think we should start the webinar with just some housekeeping. Peter, if you can move to the next slide. Just some notes before we start the webinar today. We're going to do what we can to answer all your questions during the webinar. If we don't, please feel free to ask your question through the GoToWebinar platform. You have an opportunity to use the platform to ask questions and go to your control panel and ask away. Those questions will be relayed to me, and we will try to answer them. We're going to do that at the end of the webinar, not during. We're recording today's webinar, and we will be publishing a link to it within the next few days. And when we publish that, you will be also receiving a copy of the white paper that CTS and Ranplan did together on this topic. And you can also go to magazine.connectedremag.com to read the new edition of the magazine, which has an article from CTS and Ranplan and a link to the white paper. Today's slides will also be available after the presentation, and as I mentioned, the white paper will be sent to you also. If you'd like more information about the topic, you can go to cts1.com or connectedremag.com. Next slide, please. Good. So let's start, gentlemen. Thank you for being here, both of you. So Dr. Boo, let's start with you. Can you help us understand what CBRS is all about? Can you give us a description, tell us what it is, and why it's important that people in our industry and the real estate industry understand what CBRS is all about?
Thank you, Rich. Really appreciate this opportunity to be here. Before I get into the details of CBRS, I just want to do a quick introduction of CTS. So we are a national integrator, system integrators for wireless networks. We have been in business since 1990. This year is actually 30th year, and we have 12 regions, 20 offices, about 400 people. So our business mainly is in the cellular DAS, public safety, Wi-Fi networks, and CBRS private networks. We want to become a national private network operators in the near future. So let's get into the CBRS. So CBRS stands for Citizen Broadband Radio Services. So what CTS wanted to do is to open up 150 megahertz of spectrum from 3550 to 3700 megahertz for just a spectrum utilization. So traditionally, you have licensed spectrum that's used by those are used by the carriers like Verizon, AT&T, T-Mobile. They acquire those spectrum through auction and pay for the use of the licensed deployment. Then you have unlicensed users, which are the operators in the Wi-Fi areas that use the frequency in the 2.5 gigahertz and the 5 gigahertz spectrum to deploy the Wi-Fi network. The CBRS offer a third way, which is a shared spectrum. The way the FCC want to deploy this is to allow enterprise to deploy their private network, encourage the enterprise and commercialization of private LTE solutions for all companies nationwide. Next slide, please. So in order to implement the shared spectrum, the FCC adopted 3-tiered access infrastructure. So first tier is tier 1. Those are for the incumbents. Mostly are the Navy radio stations, DoD establishments. This is protect existing customers in this spectrum. Tier 2 are the priority access licenses. This is a auction spectrum, which actually happened from July to August of this year. The auction just finished, and the FCC generated $4.6 billion of revenue, and a lot of companies involved in this auction. You have top 20 of the winners are mostly carriers, Verizon and T-Mobile, and then you also have cable operators involved in the auction, Cox, Charter, Comcast. Then you also have some interesting companies are involved in the auction are the utility companies, wireless internet service providers who want to deploy this technology or spectrum to provide internet services. Third one, general authorized access, GAA, is what's interesting to the enterprise customers. So these is a very unique feature that allows enterprise to acquire license in a fashion that you don't have to pay for it. You only need to register through Spectrum Access System. Those are the companies we call SaaS. There are currently 4 companies approved by FCC to manage the SaaS. And then you will be allowed to have 8 channels minimum to use for your private network. So next slide, please. So with GAA, the biggest benefit to enterprise is that you will be able to get a license without having to pay for it. You only need to register through the SaaS, through the company that manages the spectrum. You pay for the registration fee through SaaS, but you don't actually pay for the pay for the spectrum itself. So, and because the SaaS manages the spectrum, so it's a managed fashion, unlike the unlicensed Wi-Fi use, this will provide you a clear interference-free spectrum for you to use. You can deploy your network. You don't have to worry about some other people deploying the similar technology, similar frequency, similar channels within your property, because that's all managed. The interference, all the mitigations are managed by the SaaS companies. So because that you can deploy private applications and services, you don't have to rely on the carriers. So traditionally, when you deploy a cellular operation or some kind of voice or data networks, you need to work with the MNOs, Verizon, T-Mobile, AT&T, or some of the cable companies. In this particular case, when you deploy enterprise solution and private solutions, you can decide what you want to do, how you want to deploy it, who's going to be on your network. And that basically change how you arrange, how you deal with your carriers, deal with the other mobile operators, really level the playing field so that you can negotiate different arrangements with the carriers, such as like roaming arrangements, subleasing arrangements, or even wholesale arrangement where you deploy a network and then decided to allow all your tenants to use on a leasing basis or wholesale basis. So this really provides a lot of opportunity for enterprise to monetize and leverage the property you have, leverage the spectrum you have to deploy your private network that you have control on, and you can manage whoever going to come into property to install the system, whoever needs to be grant access to use the system. So this really I think the biggest gift FCC can give to the enterprise to deploy a private network.
Gotcha. So I was just going to ask you, second part of that question, Dr. Boo, was one of the giants of the real estate industry and most respected people actually used that terminology and said the government has given us this great gift. You agree with that, and you feel it is a great gift that enterprises of all kinds, one of the biggest bidders in the auction was the parent of GeoVerse. They won like 1,500 licenses. So I think that there's a lot of width and depth to the companies that have bought spectrum, but also the companies that intend to use it unlicensed. Do you agree with that premise that it's really a big gift?
Absolutely. So for enterprise who own the property, building owners, the venue owners, this is really one of the biggest gifts that FCC can give to the enterprise customers, because first and foremost, you get at least 80 megahertz of clean, interference-free spectrum that you can deploy at wherever you need it at your demand, and then you can allow whoever application, whatever other use case can be run on the network. So that's really the biggest benefit of GAA use or unlicensed use. And the other thing that this allows you to do is really you can use the proper user network, kind of change the table a little bit when you talk to the carriers, right? You change how your relationship with the carriers. Because if you have an important venue, you have your private network, you can start negotiating certain arrangements, differently with the mobile operators to allow certain things, certain specific applications run on your network. So this is really gives enterprise more power, more flexibility.
Right. And so I understand that 150 megahertz in relative terms is an enormous amount of spectrum compared to what the carriers actually have and have bought over the course of time. Is that correct understanding? That
is correct. So 150 megahertz is very much in line with typical spectrum owned by Verizon or AT&T in their all aggregated licenses. And there's also talks from, if you read some of the news, you'll see that there's also talks about additional auctions on C-band that's adjacent to this. So the FCC is actually are going to deploy similar mechanism in other frequencies to accelerate the deployment of private network and accelerate the deployment of 5G within the enterprise, private enterprise.
Right. So you've partnered with RANPlan, and Jonathan has been kind enough to join us today. You've partnered with RANPlan, and it seems like it must be a very important aspect of putting an LTE, private LTE CBRS network in place to do the design and do it well. Talk us through that, and then we'll go to Jonathan and understand more about RANPlan's philosophy.
Yes, thank you. That's a great question. So I think the CBRS private network is a little bit different in that it is basically from the use case and application driven. So in order to design and plan for CBRS private network, you need to start with what kind of use case application you want to deploy. So a lot of cases you have more than just the phones or smart devices you have to support on the network. For example, you have cameras, you have IoT sensors. Each of them has a different requirements. The HD cameras usually requires like 25 megabits per second speed, but most of them are actually upload speeds, right? You don't have a lot of download traffic. But IoT sensors, they usually come in very low speed, but they, have a lot of devices out there. Then you also have like digital signage. That's all downlink traffic. So there's a mix of variety of devices, different performance requirements, different use cases, applications. The reason we use RANPlan to help us to plan and design for CBRS private network is because the capability of the tool to allow us to design a network that take a homogeneous approach, that take a look at all the devices, all the requirements, be able to accommodating that. And then also a lot of the applications, or actually enterprise customers, has a mix of indoor space and outdoor spaces. Sometimes it's space connected to buildings, need to have coverage, continuous coverage. So the RANPlan has a unique feature or capacity, or capability to be able to plan and predict in those complicated environments. So that's one of the reasons we decided to use RANPlan to do a lot of the planning and designing for the CBRS-based private networks. Jonathan?
Gotcha. So Jonathan, once upon a time, there was a company that if you wanted to be in the in-building space to do design work, that was the only game in town, and you had to kind of heel to what this company wanted you to do in order to be able to say, I have the right software to design. It seems like that's changed, and it's changed dramatically with Ranplan's entry into this. And what makes Ranplan's whole mentality and design philosophy different? Talk us through that, please.
Yeah, of course, I would be happy to. And I'd say, thank you for inviting me to talk on the webinar here. So I guess up front, a little introduction to Ranplan for those who may not have heard the name. We are the new kids on the block, and as you've heard from Richard, it does afford us a little bit of flexibility in the approach that we can enable, people like CTS to be able to go out there and do. So Ranplan, and this is great, we've got video, so you'll see my hands flying around here. But Ranplan is, we're an agile and innovative software design company. So we're currently focused at providing RF planning and optimization solutions. So these are software solutions that will help CTS, engineers at CTS and others, and wireless carriers and aspiring wireless, operators to be able to go out there and design these networks, model the variables, and also model the various different challenges that they're trying to address. One of the unique things that we have at Ranplan, and one of the things, it's very much our origins, and something that we're very much involved in today is our R&D organization. So we have actively participated in and continue to participate in the standardization of new technologies such as LTE, NR, 5G NR, new radio, and that naturally brings us into spectrum sharing, so CBRS. To address your question around what does Ranplan bring to the table in this sense, what are we doing differently? First thing I'll say is this is a very exciting time for planning tools and planning tool vendors like ourselves, because we have a much new broadening audience out there. So many of you guys that are currently listening on the line. So it's no longer just talking to engineers at Verizon or AT&T or T-Mobile. We now have the privilege to go and talk to people that are new to wireless networks and connectivity systems, which in itself brings challenges to a software vendor. In terms of the technology that we're modeling, it really is a known entity. We're modeling LTE. LTE has been around for the best part of a decade, so this is the basis for many of the 4G systems that you see out there, and also 5G new radio, so 5G NR, as you'll hear it referred to as. However, what isn't a known entity for a lot of these CBRS style deployments is the whole range of new challenges that Dr. Boo alluded to. We're now not just talking about handsets or laptops. We're very much talking about IoT, and I hate that phrase, Internet of Things, because it's so broad that it doesn't help anybody make a decision on whether they should use this or not. But from a design perspective and a design tool perspective, that also brings some challenges for us, because it means that there are more variables there that we need to be able to model. And it's not necessarily exciting for us because of the evolution in the technology. Yes, that's exciting in itself, but it's actually the evolution in the way in which the technology is being applied. And that is, that's the most exciting thing to us at the moment, and the thing that is driving a lot of the innovation inside the tool. So what we've done in subsequent releases over the past 12, 18 months, as CBRS has really started to hype up and then start to come to market, is we've consulted with the likes of CTS, and we've had an open discussion. I mean, this is new to the industry. It's a new concept, and I think with any new concept, we have to work in partnership. So we had some very open, and I think some very, very, very candid discussions with the engineering teams, and said, well, look, what would you need with a CBRS toolkit? And I think that was very productive, because that allowed us to start to introduce feature functionality where we can allow companies to go out there and quantify and control the growing complexity and the number of variables that have been introduced into these designs, which are ultimately going to allow a much more accurate final bill of materials, so list of equipment that's going to go into the design, so the final cost, and also start to hone in and bring in the predicted versus real world performance of these CBRS networks that you'll see go out there. And I'm sure I'll have an opportunity to elaborate on this a little later in the webinar. But you've heard a lot from me, and I'll be quiet for now.
Right. But one other thing I do want you to cover before we go back to Dr. Boo, Jonathan, is how does all this and what you've just said create a better outcome for the end user? That's what our listeners would want to know. That's what I want to know. How does this create a better outcome?
For sure. So I'll talk about this in a little bit more detail once I've got some visual aids. But it really is controlling those potential unknowns, those variables. So one, you're going to get a solution which is relatable to the challenge that you're trying to address. So the types of devices and the types of services that you're trying to address. Ultimately, it's going to perform, which is good. It means that everybody is happy once the system's in place. But it also means that the costs are controlled as well. So you're not going in there and having to do costly revisions. It's not going to be a case of where your initial quotation may be different to the final cost in the field, because we are allowing you to model the indoor-outdoor environment. We are allowing you to add additional layers of knowledge in there. So really, it's bringing certainty in performance and certainty in dimensioning and price of those systems, which I think is important.
Gotcha. So, Dr. Boo, now I've got a better understanding of the design piece of it. So what are some of the use cases that you've seen with CBRS in specific? We all talk about, oh, it can do this, it can do that, but can you give us some specific use cases and the challenges you found in doing those particular use cases? So you've done installation work and put these things in already. And so tell us what you found and what the challenges are in a number of different use cases, please.
Sure. Next slide, please. I'd like to go through 3 use cases that we've been working on, and these are all very typical use cases for commercial real estate. First one is a cluster of residential multi-dwelling units, basically apartment complexes, that's actually located in Texas. So the diagram here shows just one area of that complex. So this is a very typical office apartment buildings with the leasing office in the middle. There's some facilities in there, pool, gym. The purpose is to cover the whole indoor space as well as outdoor space, including the outdoor common areas that the tenants or residents can use and play. And as for the CBRS use cases, the application for the CBRS is to use the phones, smartphones for internal private communication. They want to put the security camera on the system. They also want to use CBRS to provide wireless internet services to all the tenants, all the apartment complexes. The biggest challenge in this environment is to provide a solution that covers both indoor, outdoor spaces. And there's some limitations of where we can put the devices. For example, the management company does not want us to run in a cable into the apartment complex, individual apartments. So everything, every cabling, every device has to stay in the hallway. And then there are very limited locations outside to put any transmitters or radios in the common areas. So the challenge is really trying to find the proper location to hide and to conceal the radio equipment. In the meantime, to have accurate prediction to make sure those concealment will not impact our performance or any of the throughput for the surrounding areas. So we've already been using RAMPlan to do the planning stage, and then the results are very satisfying, so that the actual prediction, the actual results fairly close match the prediction, and then be able to support multiple devices and predict multiple services on the same time. So that's one typical commercial real estate deployment examples. The other one is a outdoor shopping center. This is in West Coast. So it's outdoor premier shopping center that has very high-end shopping. And then the parking lot is outdoors. the corner of the parking lot, there's a high-end car wash place. And then in the middle of the parking has a Uber. With COVID-19, it doesn't really being used that much, but before COVID-19, there's an Uber place where the visitors can call the Uber and then get the message sent to the phones. So the purpose of the solution to provide coverage for the shopping center, the storefront, all the packed walkways, pedestrians, and parking, and then back house areas. As I mentioned, the car wash area has IoT sensors to make sure the car goes through. There's no water, there's no oil leak. Every car is clean. All the cars being washed to clean all that. So it's a very mixed use of CBRS devices. So the management of the shopping center wanted to use that for private communication, typical security cameras and push-to-talk, and I mentioned the IoT sensors, and also to be able to provide coverage or services for the Uber rideshare locations. So this is I would say, a very common situation for shopping centers. So that deployment is actually we had designed. It has not been implemented yet. So, and we also use the RAM plan, and then they're able to predict the coverage, because one of the limitations is that all the antennas needs to be hidden under the facade or under the wall, and then all the outdoor elements needs to be hidden in the bushes, and then all the remote cameras, there's no way of running fiber to those locations, so we have to use CBRS as a way to bring the traffic from cameras back to the control rooms. So there's a lot of limitation in this particular case, and then with the RAM plan, we're able to do all the prediction and all the planning perfectly. A third one is probably the most common use case in the commercial real estate world, is the mixed commercial building with office, retail, and parking garage. As you can see, this building complex is in the southeast, and they're still in the planning stage. The customer has offices on top of the building, and then the middle is the shopping areas, retail space, and then the parking garage is the bottom. So the requirement is to provide coverage all throughout the facility, including the walk path from the building down to the parking garages and outside, and also make sure the smart parking has all the sensors connected to the network, and then there's executive parking there, and make sure the exec parking is always open, and the executive has continuous coverage from his car through the elevator to his office all the way to the top, and also has sensors to make sure his car has no oil leak, has enough gas. So those kind of things, very unique demands for a IoT applications. So we were also use the RAM plan to do the prediction and planning and the design for this particular application. And then this is still in the planning stage, so it has not been deployed yet. But as you can see, the very common theme for a lot of commercial real estate is the internal communication, security cameras, and then building related IoT, some kind of IoT sensors that can deliver special cases for building management or some kind of a special application.
Gotcha. So are these all situations that have been installed? You said the third one was in the design stage. So you're working on a RAM plan design and you're doing the implementation, but are the first two already installed?
No, the last one is in the planning stage. The second one is we're about to start construction, but COVID-19 kind of pushed things out. The first one is we had some trial. We did a small trial. It's working on the trial, but we were not able to deploy the full scale. Similar reason due to COVID-19.
Gotcha. Okay, good. So those are important use cases, and I guess that's one of the things, we've all talked about the American Dream Entertainment Center. I'm not allowed to call it a mall. Obviously that's got problems with COVID-19 opening itself, but the we're all talking about things getting ready to go and testing, but do you see this as a great push that enterprise clients are working on, or is it still something that people are simply dipping a toe into? What's your sense of the enthusiasm? And you both can comment on this. What's your sense of the enthusiasm for getting this done and getting this installed now?
I think certainly the COVID-19 situation has slowed down some of the development of this CBRS private network, but we do expect a lot of pent-up demand in the next year or so, because a lot of enterprises look at this technology and they look at this as alternative to existing cellular or unlicensed Wi-Fi technology. They do see the potential of this CBRS private network. They see the capability of the network to be able to bring different technology, different networks together into one common network. And some of the things we're also working on are capabilities to bring voice and data onto the network, so that be able to allow the users to use your cell phone on the private network side. So we do expect, actually, starting 2021, you see probably a huge rise of private network deployment using CBRS.
Got it. So Jonathan, you share that impression too about what's coming from this, and you obviously work with CTS and others. What's the amount of design work that people are coming to you to do?
I would say, given CBRS is very much a hot topic, so I would say of the people currently using Ranplan or evaluating Ranplan or coming to us and saying, hey, what can you do, Ranplan? What can you help us with? I would say more customers and potential customers are looking at CBRS as a new revenue stream, a new potential, not just a revenue stream in terms of, hey, we're going to go out there and, okay, we can sell some equipment or we can sell some design services. But people really are, like Dr. Bu described, seeing this as a way of evolving their own business into either becoming, a wireless, internet service provider, essentially expanding managed service portfolios, but also a way of, in essence, allowing a lot of innovation into the industry. And I think that's yeah. So I would totally agree with what Dr. Bu said, and I think you'll see a lot of innovative solutions going out there, because this is in a sense less restrictive than carrier DAS. We can come up with new creative solutions for addressing these challenges. So I think COVID hasn't helped, and I think there's always that period of hesitation, because people don't really want to be the first to try this. But I think once we start to see a few tried and tested use cases going out there, which there certainly is, as you've seen from the slides, and there's more you can look at, I think you'll start to see in 2021 things really snowball for CBRS, not just in the US, but for spectrum sharing globally as well.
Got it. So let's keep going with you, Jonathan. So we've seen the use cases. How does the design strategy and what you're doing help to predict better and make these use cases sort of more robust, if you will? And what makes Ranplan superior? What factors are you taking into account when you're doing your designs that make this a superior design for when Dr. Bu gets there and starts the install, and then they try and match what you planned, and in some cases that doesn't always match. In your case, you're doing a better job with that. Talk us through that. And I think you've got another slide to show, right?
Yeah, of course. So I have some visual aids on here, and that's a really good question, actually. So I'm not going to go out there and be big-headed and say, we're the best in the world at doing this. I think we just have the advantage of being the new kids on the block, is what it comes down to. And just like CBRS and spectrum sharing is opening up a lot of potential for innovation with the way that the integrators and WISPs address a lot of these challenges. Us being newer to market also opens up a lot of potential for us to innovate and do things differently, because we're not necessarily locked into very traditional notions of how a design should be done, what should be the inputs, what should be the outputs there. So as you've seen from the use cases or the examples that Dr. Boo presented, CBRS is a massive opportunity. You know, it's a massive opportunity for connectivity. It's a massive opportunity for integrators, WISPs, corporate real estate owners alike. However, it does have its own unique set of challenges that we as Ranplan have gone about trying to help address. So these challenges, as I described previously, can have a material impact upon the projected versus actual cost and performance of a system. And these are, you know, can be very big things, or very impactful, should we say. And a lot of the approaches that we're starting to see in addressing these challenges are new. You know, they aren't tested. They aren't things that have been done for 10, 15 years. And in a sense, that's a really cool thing to be able to say. We are at the bleeding edge we very much are. So as we see a much broader usage of the technology, it's going to become much more difficult and potentially riskier just to rely on simple KPIs. So for carrier DAS, you often get a simplification of KPIs to say, look, I need X metric over Y percentage of the floor area, and that should get us within an acceptable tolerance of the system performance, and that should allow us to have the system dimensioned. However, what we're really now seeing with CBRS and with spectrum sharing, I guess to call it a broader name, is a transition towards application-driven planning and optimization. So that really means tuning the solution that is being presented and being provided to the challenges that it's intended to address. And that sounds like common sense, but I think we've been guilty in the past in telecommunications because the challenges that we're trying to address are very narrow. And now we're trying to address some very broad challenges, which is a good thing to be, you know, it's a good thing to have to do. So in this sense, CBRS for real estate owners and WISPs isn't about connectivity in a traditional sense. You know, it's not, for example, I want to connect my cell phone or I want to connect my laptop. It's now, as you heard from Dr. Boo, I want to connect this whole plethora of devices and different service types that have different metrics that they have to meet. And I want to assure that, you know, if somebody does make that voice call because it's connecting back to the carrier system, that it's not going to knock the video cameras off, for example. So to address what we're doing as a company or as a software tool, what we're doing is we're starting to add in additional layers of logic that a designer can start to consider. One of those is the ability to consider the outdoor environment. And as you can see from the slides and the pictures that are up on there, one of the things that you can do in Ranplan is you can bring in geodata, you can bring in a much wider context. And you have to pardon the pun here, but in that sense, you know, Ranplan does allow you to think outside of the box when addressing these challenges. And in this sense, the box would be the building. So traditionally, telecommunications designs have been very focused on building to building, project to project, where in reality, what people are looking for is seamless connectivity, whether they're transitioning between the indoor environment and the outdoor and vice versa. And seamless connectivity in a sense that, okay, we now have a whole load of different devices and usages that we have to serve with these systems. We don't want to deploy a different system for each one of these, because that's not going to be feasible. So the other layers of logic that we've also introduced into the tool is to be able to model those different device types, because they perceive the performance of the system differently. I mean, you see even with handsets, and you know, you may see brand A, because I don't want to get called out and sued by anybody, but you you may have different types of handsets will see the network performance of the network differently, and just in that concept, different connected devices will perceive the network differently.
Right. So That's good. I was going to jump in there and ask you about that because my understanding early on from Rand Plan was that was one of the major features was bringing the outdoor and understanding the outdoor environment into the building design where signal was coming into the building. So I'm glad you covered that. Dr. Boo, it's very important that the audience get an understanding of what CBRS can do for them in relation to one of the biggest issues out there, 5G. So we see that Apple introduced their 5G phone today. How does CBRS and 5G and IoT and other things fit together? How does that work? What is the grand plan for CBRS to get me 5G in my building, to get me IoT?
That's a great question. So the CBRS Alliance has adopted 5G NR standard as of end of last year. So there work to be done to deploy or adopt 5G NR standards into the CBRS spectrum. So that's being worked on right now. So you'll probably see more 5G enabled devices or what we call CBRS and end user devices in the market in the next few months until probably end of the year, next year as well. You see a lot of these manufacturers started to design and manufacture the devices that can support 5G NR in the CBRS band. With the 5G NR, the CBRS private network can support much wider, broadband services. Take advantage of the whole 150 megahertz, and also be able to support. Yes.
I'm sorry. Let me see if I understand correctly. So I can actually use the CBRS frequencies and run my 5G protocol so that will be the way I will be able to get 5G in my building, regardless of what the carrier is doing outside of my door.
Yes, exactly. So if you have the capacity or capability to utilize the whole 150 megahertz, you have potential to reach the 1 gigabit per second throughput. And then that gives you much more capacity to support all the devices. Especially you can deploy low latency security solutions for your facilities, highly reliable solutions for your buildings and everything, and also massive IoT type of deployment. Say for example, in a manufacturing plant, you can bring all the IoT sensors, IoT devices, scanners, processing plants, autonomous vehicles onto the private network, and then because of the improved 5G capacity through the deployment of 5G NR standards.
Good. So one more question on that, and we've got more questions from this webinar, which I think is a fantastic indication than I've ever had for a webinar before. So I want to get to those, but last kind of important question is, to install CBRS in my building, am I pressed in any way to wait for the replacement cycle of phones? Because now Samsung does have CBRS in it. The iPhone does have CBRS in it.
iPhone 11, yes.
Yes. The Pixel from Google has it. But do I need to wait till every person in my buildings has now gone out and gotten a new phone with this, or am I somehow capable of using CBRS effectively in my building until that replacement cycle is completely done?
I think that's a great question. Actually, CTS is partnered with the two other companies trying to roll out what we call neutral host CBRS program. The idea of that is to allow the enterprise customer to deploy a CBRS network while the upgrade cycle catches up, because we expect within a year or two, the 50% or so of the devices out there will be CBRS enabled. So this program is unique such that the enterprise customer pay a very low down payment, then be able to utilize a neutral host CBRS network to provide you cellular type of voice and data services. And then once the CBRS devices are penetrating through the market, you'll be able to have the roaming arrangement with all the metro MNOs and all the public networks. So you have one network support your private use as well as the public use from all the cell phone smart devices into your building.
Using a dual SIM type phone, correct?
Dual SIM, that would be something that's available now, but couple of years from now with this neutral host model, you don't have to have a dual SIM. Any phone that supports CBRS will be able to ride on this network, be able to seamlessly transition from outdoor into the outdoor public network into the private network inside, as well as transition from private network indoors to outdoor public network.
Got it. Good. Okay. So if you both wouldn't mind, I'd like to start to go to the questions. It's right at
Sure.
45 minutes, and they're fantastic questions.
All right.
There you go.
I'm glad there's a lot of questions here.
I have to tell you, you've created a lot of interest out there. Dr.
Absolutely.
Boo, this is for you. What do you see as the top 3 smart building scenarios a property manager owner should implement first?
So far, we've seen the top 3 applications or use cases are security cameras and internal communications, and then building management systems. The building management systems are coming up, especially after COVID-19, because the access control, the contactless applications becomes more and more important for building to control the access, make sure you track all the movement of the personnel, make sure that kind of scan people's temperature, things like that. So those are the 3 main use cases we've seen in the commercial deployment.
Right. Okay. So could you say that real estate control gives the enterprise more control over the wireless infrastructure too? Is that sort of it? If you control the building, do you control your infrastructure better if you have that control?
I would say so, only because the CBRS allows you to also control one of the biggest asset, which is a spectrum. Once you register through the SAS and you are granted license, which is good for 3 years, those blocks of frequency would be assigned to the enterprise customer to use, and then the SAS will manage and mitigate any interference that your system might have with other building next door, or tenant within the building. So that, since you control the premise, control the infrastructure, now with the added piece that FCC allows you to control your spectrum, you really have control of the full aspect of all the wireless infrastructure within your building.
Gotcha. Jonathan, we'll get to you, but one came in for me. It says, Rich, I've noticed in past webinars that property managers are intrigued with CBRS long-term, but it seems slow to embrace short-term. Why do you think that is? And I would say the answer to that, from my perspective, is that COVID has slowed down the process of people doing a lot of things, not just installing CBRS or DAS or anything else. But I think that there is still that question mark in people's minds of the dichotomy between the Verizon commercials that bombard us every day and the fact that 5G really isn't here yet. And so that's confusing people. But I think that the best methodology and the pathway to 5G will be CBRS. And I think this will accelerate things dramatically in short order as soon as we get back to normal. It is a good time to actually go into buildings and fit out, because people aren't there every single day, and there isn't a crowd in the building. In some cities like New York, it's 10 or 15 or 20%. So that's just my opinion. You answered the question about the sample use cases. Are they examples, or will they be done with CBRS? I think you answered that one. What type of PTT technology is utilized in the examples you gave? I don't see any push-to-talk technology being utilized in those things. Did you, Dr. Boo?
So currently, Motorola has a push-to-talk phone that's CBRS enabled. So we have tried out the push-to-talk devices from Motorola. So one of the features of that is you utilize the CBRS band and LTE-based phone, push-to-talk phones for communication, for voice communication. And then also the phone can be turned on to hotspot to provide connectivity to Wi-Fi connectivity to some of the surrounding devices. So if they need more information, any person need more information, they can contact us directly. I can provide them specifics about the push-to-talk device.
at cts1.com.
Yes.
Good. Jonathan, this is a perfect one for you. Could you get a broad sense of how much gear, how much radio gear, they're asking, needs to be implemented to propagate CBRS signal in the 2 outdoor settings that we used as use cases before? How many radios do you need, or maybe it's an antenna question, but how much gear do you need to do an outdoor area with CBRS, given that it's a good, robust frequency to use?
So that's a really good question, and it's one of those questions that really is, how long is a piece of string? So I think one of the things that, and I'm sure Dr. Pu will agree with me here, one of the big things, I guess, as a commercial real estate owner, that you can ask yourself when you're talking about CBRS is, okay, what do I want to address with the CBRS system?
That's right.
Am I going to use, one of CTS's upcoming solutions, and am I going to use it as a neutral host? So am I going to use it for phone calls and data transactions over a carrier network? Or am I going to do this because I don't want fiber cabling everywhere? I don't want to pay for that. I don't want the nodes visible, for example. And also, what am I connecting to the system? Because you're going to need more equipment if you have video cameras, for example, and if you're doing VR, for example, and you have to have these high throughput sensors. So it's really going to vary the amount of kit that you put in there. However, one thing that I will say is the topology and the way that this equipment is deployed is a lot less invasive than, say, a traditional carrier DAS system, which may be very attractive to commercial real estate owners.
But I'm committed to giving people as good an answer in general as we can. So Dr. Boo, could you say that if we said we had one radio per 10,000 square feet, per 5,000 square feet, per 1,000 square feet, if I put a gun to your head and insisted we get some general average of that, what would you say the square footage would be?
You really put me on the spot. Don't quote me, but we, based on our experience, some of the examples we've run, I think what we call Class A, which is indoor radio, typically will cover between 5,000 to 7,000 square feet for indoor environment.
And what
Outdoor is a Class B radio. So we've done some prediction where depends on the use cases. If it's just particular, very traditional, coverage perspective, we probably can cover a radius of 600 to 800 feet radius. That's just for typical data, voice and data. But to Jonathan's point, the coverage footprint shrinks if you have cameras, because it's a huge data hog of spectrum. So if you have a lot of cameras or sophisticated cameras, it really depends on how much spectrum you have, how many channels you have. That really shrink down the footprint. And we've also did some outdoor. I'm not talking about a cellular perspective, more on the wireless internet service provider perspective. They use CBRS to provide wireless internet service providers using the outdoor radios. That can cover roughly around a mile radius. That's assuming that your antenna radio is putting at like 50 feet or to 100 to 75 feet, small tower, small cell kind of deployment.
I'm sorry, I didn't mean to step on you there. That's why I pressed you for an answer. So the next question is perfect lead in for that. It's we have a new reality now, and this is a really good question. The workforce has moved to residential areas, suburban areas, rural areas where the bandwidth is limited and there are fewer fiber optic network deployments. The notion of putting 10,000 people in a building may be a thing of the past. How would you apply CBRS in this scenario? And I think you both covered this with the word WISPs, or wireless internet service providers. So
yeah, fixed wireless access, basically.
Yes. So that someone in a rural area who might not have coverage, that a company or an individual could come in using CBRS frequencies and cover a mile radius of suburban or rural households using
That's right.
CBRS. So CBRS is great for the 10,000 people it might be in a building, but it's also a great situation for rural areas to use with wireless internet service providers. So I think we've answered that question too, and thank you for being on the spot a little bit and answering that. But
Yeah.
I think that's very important for this. Can the infrastructure of an existing hybrid DAS be utilized for deployment of a 4G private LTE network? Not sure exactly what they mean by that. Please describe what infrastructure components, if any, can be used in lieu of a rip and replace scenario. Way over my pay grade. You guys, Dr. Boo, you want to start, and then Jonathan, you can answer that.
I think that's a great question. Actually, we have some explanation in our white paper to really explain 4 different types of deployment as far as the radio distribution network. One of the scenarios is to utilize the existing infrastructure to add another CBRS layer to it, and you can utilize a hybrid model where there's existing 4G LTE cellular DAS infrastructure, then you can add a private a CBRS layer to it. Or there's also a replace model where you deploy a small cell-based infrastructure that supports CBRS as well as other technologies. So
Jonathan,
if you download the white paper, there's more detail in there.
Gotcha. Okay, I'll send everybody there. Jonathan, propagation at 3.5, which is where CBRS is going to be different than someone who had a network, a DAS network in their building that propagated up to the Sprint 2.5. Does that mean that the antennas would need to change and the design would really need to change? Or are they in good shape where you could do a rip and replace, a simple overlay on their DAS system?
So that's a good question, and it's going to depend. So in terms of coverage footprint for 3.5, it's going to be a function of the technology that you deploy over there. Obviously, with CBRS, we have a much higher channel bandwidth than is available through 2.5 or 2.6, for example, which is going to affect the propagation. Also, you have to look at a function of power. So as Dr. Boo talked about, you have Class A or you have Class C nodes. So one of the appealing things about deploying CBRS outdoor, or for maybe an ODAS or an e-ticketing replacement sort of thing, is you can deploy with an additional, I believe it's 10 dB of power, which is actually quite a significant amount of power that you can increase the coverage radius with.
I'm sorry, I didn't mean to cut you off. We're tight for time, but there's another RAN plan question here I wanted to make sure I gave you. Can RAN plan do on-site surveys anywhere in the US? Is it necessary to go on-site, or does RAN plan typically design systems remotely with floor plans? So I didn't want to miss that question for you, Jonathan. I'm sorry I cut you off.
No problem at all. So yeah, so let me finish off what I was saying very quickly, because the only other concern that you would have is if the antenna was spec'd for that frequency band and number of channels and channel size. In terms of how RAN plan as a tool goes about doing the designs, you wouldn't necessarily need site access, but there is a level of information that is required to model the site. So that may be things like floor plans, CAD files, maybe some imagery to help understand the nature of the site. So given the current situation, you wouldn't necessarily need, continuous site access, which I think is.
Can you go anywhere in the country to do that?
So we are a software tool provider, but I'm sure Dr. Boo would be more than happy to help you guys out with that.
Gotcha. Well, that's good. That's good.
I want to add a little bit before we wrap up. So to Jonathan's point, the previous question, we always recommend is just our client to have the DAS infrastructure be able to support from 600 megahertz all the way to 6 gigahertz. All the components need to be capable to support that. On the site survey side, on the RAN plan capability, because we have capable of uploading the geo data So that's why a lot of the time you don't necessarily have to go to the building to do the site survey, because the geodata, terrain, the clutter, all those information will help the tool to produce a very accurate prediction.
Gotcha. So I'm going to just run through a couple of these. This is really quick. Is 5G NR ratified by CBRS Alliance? CBRS doesn't ratify technologies, do they? Or is that part of what
Yes.
they're...
So that is what they did. Yes, they already CBRS Alliance is a entity that set up standards for deployment within the CBRS band.
Gotcha. And so they have...
So they will be the one.
5G
yes,
NR.
Yeah.
Gotcha. Okay, that's good. What about millimeter wave? There's a great, issue that's out there. What about millimeter wave in this situation with CBRS? Do millimeter wave 5G with CBRS?
Yes. No, you cannot do that, unfortunately. Millimeter wave is a very much higher frequency than CBRS. So it's almost 10 times higher. So it means anything frequency about 28 gigahertz, 24 gigahertz, I'm sorry. The CBRS is referring to 3.5 gigahertz. So you see there's a huge difference on this spectrum, on the frequency range. So millimeter wave is not going to support it by the CBRS.
Gentlemen, we are out of time. We've gone a minute or two over, but that was fantastic. The questions were wonderful. We had an enormous audience today that was on. And so I thank you very much. And thank you all for listening in today. You will get this email to all of you if you registered for this event. And gentlemen, thank you so much. This was really informative and you were terrific today. Thanks very much. And
take care. Thank you.
Saying thank you for being here.
Thanks.
Thank you.
Pete, we're clear.